We constantly hear that you can't solve a problem if you can't accurately measure it. And when it comes to human welfare, that couldn't be more true. Welcome to this explainer. Today, we are diving deep into a rigorous academic review of econometric poverty models. We're going to pop the hood and look at the exact statistical tools and formulas economists use to quantify poverty, inequality, and vulnerability.
So here's our game plan. We'll be using a micro to macro to future framework today. We're going to build up from individual household baselines, scale all the way up to societal inequality, and finally forecast future vulnerability using regression techniques. As you can see, we've got 6 parts to cover, taking us from the raw definition of poverty all the way to data-driven policy solutions. Let's get into it.
All right, let's kick things off with Section 1, Defining the Poverty Line.
Right off the bat, to start measuring poverty, we first have to establish the threshold, right? We need a baseline of what it actually means to be poor. And we can basically split the academic debate on this into 2 main methodologies. On one side, we have objective approaches. The most common method here is calculating the literal cost of basic needs. Think of this as the pure math. You estimate the exact cost of acquiring enough food for adequate nutrition, usually around 2,100 calories per person per day, and then you tack on the cost of non-food essentials like shelter and clothing. On the flip side, we have subjective approaches. Now, this is still analytical, but it relies heavily on the human experience. We're directly polling populations and asking them, hey, what do you personally feel is the absolute minimum income needed just to make ends meet?
Now, when policymakers want to evaluate the real-world effects of their programs over time, they almost always rely on an absolute poverty line. This is a fixed standard adjusted only for inflation. Mathematically, it calculates the threshold as a function of local prices, demographic characteristics, and a minimum baseline utility. An absolute line is super important because it allows us to evaluate poverty trends without the goalposts constantly shifting. Though, in practice, it is tricky. It requires some incredibly complex adjustments, because a small household in a rural farming area faces a totally different economic reality than a huge family living in a major city.
Moving right along to Section 2, Measuring Poverty and Severity. Okay, this is where it gets really fascinating. We are moving beyond just doing a simple head count to actually measuring the depth of poverty. Economists use the Foster-Greer-Thornbeck or FGT class of measures for this. It introduces progressive mathematical complexity. So P0 is just your basic headcount index, the simple proportion of people below the line. P1 is the poverty gap index, which measures the depth of poverty by looking at how far below the line individuals fall. But the poverty severity index, P2, is where the statistics get incredibly powerful. It mathematically averages the squares of the poverty gaps. By literally squaring that gap, someone who is $10 below the line suddenly carries exponentially more statistical weight than someone who's just $1 below. It intentionally forces governments to focus their resources on the absolute poorest of the poor. And this Madagascar data from 1994 brilliantly illustrates why P2 is such a game changer. Look at the contrast between unskilled workers and herders. Unskilled workers have a headcount poverty rate of 62.7%. That's the 3rd highest on the board. Herders, on the other hand, have a lower headcount at 51.4%. But check out that final column, the poverty severity index. The herders actually have a higher severity index than the unskilled workers. What this means is that while fewer herders are poor, the ones who are poor are experiencing much more extreme deprivation. If a government only looked at the basic head count, they would completely overlook the people suffering the most.
We also absolutely have to talk about the Sen Index, created by Nobel laureate Amartya Sen. This was a massive paradigm shift in welfare economics, and it's a core analytical tool today. Why? Because it combines the head count, the depth of poverty, and the Gini coefficient of inequality, specifically among the poor. Instead of just asking how many people are poor, it actively measures the income distribution and inequality within that vulnerable group itself. It's a brilliant concept that gives us a much richer, nuanced picture of welfare.
Next up is Section 3, Indexes of Income Inequality. Let's zoom out from the micro-level severity we just discussed and look at macro-level societal inequality across the whole population. The Gini coefficient is definitely the most popular way to show overall dispersion, ranging from 0 for perfect equality to 1 for perfect inequality. But economists heavily rely on general entropy, or GE measures, like Thiel's T and L, as well as the mean log deviation. And there is a very specific reason for this. Unlike Gini, these GE measures are additively decomposable. Simply put, they let us cleanly slice the inequality pie into categories, completely separating the inequality happening within a specific group from the inequality happening between different groups.
And here is the real kicker. When you use these decomposed metrics on national data sets, you can prove something that usually surprises people. We tend to assume inequality is mostly driven by between-group differences, like, the massive wealth gap between urban and rural areas. But these decomposed metrics consistently prove that typically a whopping 3/4 of a country's inequality comes from within specific groups, not just those broader geographic divides.
Moving to Section 4, Poverty Mapping and Profiling.
So, all this math is great, but how do we actually locate these marginalized groups on a real physical map? The answer is poverty mapping. It's this incredibly powerful statistical technique that combines different data sets. Step 1. You run a detailed household survey to gather deep, accurate welfare data. Step 2. You economically relate that poverty data to variables that are also found in a broader national census. Step 3. You apply that newly formed regression equation to the massive census data. It is literally statistical magic. Researchers can take a relatively small household survey and accurately predict and map poverty across an entire country, allowing governments to target local policy interventions right down to the village level.
Now for Section 5, Quantifying Vulnerability to Poverty. Okay, so we've established how to measure the present. But what about the future? Let's talk about quantifying vulnerability. First, we need to understand the difference between chronic and transient poverty. Chronic poverty means a household is poor in all periods. They are stuck there. Transient poverty means a household might be doing okay today, but if they suffer an economic or environmental shock, they could stochastically fall below the line tomorrow. This introduces a huge statistical challenge: measuring vulnerability. Economist Stephen Darkon defines this as ex ante poverty, which is the literal mathematical probability of a family falling into poverty next year.
So how do we actually calculate this probability? Well, economists use cross-sectional data to run a series of main regression techniques. First, they regress the log of per capita consumption on independent variables. Then, they square the residuals to estimate idiosyncratic variance. Finally, they predict the expected log consumption and use a normal distribution to calculate the precise probability of falling into poverty. If that sounds super dense, don't worry. In plain English, they are isolating what a family expects to consume and the mathematical variance of that consumption to pinpoint the exact determinants and shocks that make a household vulnerable.
Let's look at a detailed analysis of this in the real world. The Indonesian poverty case study during the massive shocks of the Asian financial crisis. Researchers applied these exact regression techniques to Indonesian data from 1998 to 1999 to see how the crisis affected poverty trends over time. They objectively categorized households. Highly vulnerable men to household had a greater than 50% probability of falling into poverty. Relatively vulnerable meant a 22 to 50% chance. This robust economic analysis revealed what we call a hidden iceberg effect. The vulnerable population at risk of falling into poverty was actually far, far larger than the population that was currently poor.
And finally, Section 6, Data-Driven Policy Solutions. So, what does this all mean for us? How do these rigorous econometric models inform national poverty reduction strategies? Well, robust data helps governments move away from just giving out reactive handouts and towards forward-looking, highly effective poverty reduction policies. By using these severity indices, spatial mapping, and vulnerability regressions, policymakers can design heavily targeted safety nets. They don't just treat the current symptoms of poverty anymore. They can mathematically anticipate and prevent future vulnerability way before a household ever falls over the edge. It's a total game changer.
But I want to leave you with this provocative thought to chew on. Armed with all this incredible forecasting data, how should a society actually balance its budget? Do you dedicate your limited resources to saving those suffering in severe poverty right this second? Or do you prioritize protecting the massive group of people the models predict will fall into poverty next year? It's a complex, mathematical, and ultimately moral question. Thank you so much for joining me for this explainer.